Okay, welcome to Algebra 2.1. This is a review of systems. We will be solving systems by graphing. Now, the first thing that you need to know is what a system is. So, I would say down, well, actually maybe up at the top of the page in the margin, we could write the definition. A system is two or more lines graphed on the same grid. That's what a system is. So it's when we put two or more lines on one grid. Now the solution for a system, probably on a separate sheet of paper, solution to a system, well, if you think about it, the solution for one line was any time that a point fell within that line and made it true. So a solution for a system is the point of intersection on a graph. It's where they cross, or if they happen to share more than one line, then it's every point that they share. If you're not looking at a graph and you're looking at the equation, it is the point that makes the equation true. And it's not just one equation, it's both. Point makes both equations true. Okay, so let's get to solving a couple systems by graphing. Now, if you think about two lines like two pencils, if you have these lines, you can line them up this way. Would they ever cross? What do we call that when they're lined up like train tracks? Those two lines are parallel. Will they ever cross? Would they ever share a point? Those lines would be called no solution when it comes to the system solution. Another thing that they're said to be is that they are inconsistent. Now, another option for these two lines, they could nicely cross. And then the solution would be right here at their intersection. That would be one solution, and you would give the actual coordinate of that point where they're crossing. And we would say that that is consistent because there is a solution. And it's also independent because around that point, these two lines could wiggle and move. So they're still independent of each other, except for that one point, which we say is consistent. There's one other option for two lines and their solution, and that is when the two lines slide together and end up on top of each other. Well, it would be consistent because there is a solution, but every point inside of this line is shared with the other line. So we say there's infinitely many solutions because there's infinitely many number of points. But when we list the consistency, they're still consistent because of the solution, but now they're no longer independent, because if the line were to move, the other one needs to stay with it. So they're dependent of each other, consistent, dependent. Make sure to write that in your notes. Pause the video and write all three of those definitions down. rewind this video if necessary, but you need those definitions. Okay, here is the first graph that we're going to do. In order to graph a line, I always request that you get the y alone. So if you look at these, over at number 3, we have one with y alone. Let's graph it first, just so we remember how the graphing goes. We have y alone, so we look at it as y equals mx plus b. Remember, b is our y-intercept. That's the point that we find first. So when we look at this graph, the number that's not associated with the x is 2. So that would be our y-intercept, the point at which we're crossing the y-axis. So we find the y-axis, standing on its leg, and we go up to 2 and we put a dot. Now, we go back to our equation. There's just a negative in front of that x, but we know that there could be a number. Now, if it were 0, then there would be no x's. The number in front of that x would need to be a 1, since there is an x in this equation. It also has to be a negative 1 because there's a negative. The m value attached to the x is our slope. We always look at it as a fraction of rise over run. If we have a value of negative 1, then that must be 1 over 1. So from this point, we rise 1, and because it's negative, we run to the left. Left is always negative. Now, we will graph. I'm sorry, I did not grab a ruler. So I'll just improvise and use a straight edge. So there's our first line. Please take it clear across the grid, because I want to make sure that wherever the intersection is, that it does occur on that grid, and it might occur somewhere that I don't realize it's going to. So now we come to our other equation. Negative 2x plus y equals 5. And I need to get the y alone. So I go back to thinking he's the creepy dude. I draw the line. I go up to PIMDAs, looking for what's being added or subtracted on the y side of the equation, on the creepy dude side. It happens to be negative 2x. To get rid of a negative 2x, I would add 2x. I have to also add this over here. This wipes out, and we get y. Now, if you have coins in your pocket and dollars in your pocket, you don't just add them all together and say you have that many dollars or that many coins. Same thing here. You can't add your x with your whole number. So we have to separate it out. It's like dollars and cents. It's 2x plus 5. Now we look at the y-intercept. The one without the x is 5. The slope would be 2 over 1 because it's attached to the x. So we go from the 5, we rise 2 approximately. And this time it's positive, so we run to the right one. Now, because I'm off the grid, I might be a little bit off. So as I bring my straight edge in, I line it up and I make sure that I'm also crossing through the point that's down 2 and over 1 this way. Well, I see that they do intersect. These lines have a single point. That point is at negative 1, positive 3, and you must put the answer in a point form. And then you should also label this as consistent independent. Okay, moving backwards to the next graph. Well, we want to graph this, we need to get the y's alone. So we have 3x minus 2y equals 10. Get the y alone. Subtract 3x from each side. We get negative 2y equals negative 3x plus 10. To get the y alone, we divide by negative 2. A negative divided by a negative is positive, so this becomes 3/2 x. And negative 2 goes into 10 negative 5 times. To graph that, we go to negative 5, the y-intercept. Then we rise 3 and run 2. We rise 1, 2, 3, and run 2. We draw a line through that. And now we solve the other one, which is 3x minus 2y equals 2. We subtract 3x from each side, and we have negative 2y minus 3x plus 2. Now we divide each side by negative 2. We get y equals, 2 negatives make a positive, so it is 3/2 x. Negative 2 goes into positive 2, negative 1. We go to negative 1. We rise 3, run 2, and we draw the point, or draw the line. What is the solution? These are both parallel, so it's no solution. Also known as inconsistent. Okay. Next system, we need to solve these equations. I'm going to use some of the room in the margin here to solve this. So we have 2x plus 5y equals 6. I subtract 2x from each side. I would get 5y equals negative 2x plus 6. Now I divide by 5 everywhere, and I get y equals negative 2/5 x plus 1 1/6. I've just reduced this into a whole number. Since it's my y-intercept, I like it in whole numbers so I can find the boxes easily. So I come up 1 box and 1/6 more, make a mark. That's my y-intercept. From there I rise 2, 1, 2, and I run 5 to the left. 1, 2, 3, 4, 5. Now I draw my line. And now I have to graph the other one. 4x plus 10y equals 12. I'd subtract 4x from each side. I get 10y equals negative 4x plus 12. I divide by 10 on each side. Y equals negative 2/5 x plus 6/5. I realize this is the same equation as that equation. So now I know these are infinite solutions, and I show that by putting 2 arrow tips indicating there's 2 lines there. I write infinite solutions. And I write consistent, dependent. One thing that you might want to note is that when you have infinite solutions, you've got the same slope and the same y-intercept. When you have no solutions, you have the same slope but different y-intercepts. That will come in real handy as we do some application and problem solving in class. That is the conclusion of the 3.2 or 3.1 systems. Let me find your assignment. It is, when you get to class, it is page 156, number 1 through 33. It's the next pages where it's listed. It's this first section, that's with the graphing. You need to make sure and practice this and be competent at it, even though it's review.